So we continue our discussion on phase and phase difference here. So we have this diagram which we used, and I have written down a few things over here. So let's get back to these 8 particles that we talked about, and we found out that the phase of these particles. This over here I have written the phase of the particle, which is denoted by the symbol phi. The phase of particle number 1 is pi, phase of particle number 7 is 1.5, and like this we have different phases of this particle. And once again, to quickly recap, the phase of particle pi is particle 8 is pi because it has completed 2 amplitudes motion, and 1 amplitude motion is pi by 2. That gives us pi. And in a similar fashion, we have got this. The phase of particle 1 is more than particle 8, or the phase of every particle which is preceding particle is more because it would have completed more amplitude oscillations. So that's phase. Now we come to phase difference. So if we try to find out the phase difference between particle 1 and all the other particles, we'll get something like this. The phase of particle 1 is 4.5, the phase of particle 8 is pi. So the phase difference between particle 8 and particle 1 is 3.5 pi. 4.5 minus pi, 3.5. Similarly, phase difference between particle 1 and particle 7 will be 4.5 pi minus 1.53 pi. And like this will be 2.5, 2 pi, 1.5, and so on and so forth. So this is the phase difference between the particles. And once again, this phase difference is there when we've taken a snapshot of this at that particular instance. This is the phase difference with the particle at that instant. So this can be denoted by the symbol delta pi, phase difference between the particles at a given instant. Phase difference can also be obtained in terms of wavelength lambda. So this is the starting point. It's 1 and 2. This will give us one wavelength. This is divided into 4 parts, part 1, part 2, part 3, and part 4. So these 2 points, this length is the wavelength. And we can see the phase difference for wavelength lambda is 2 pi. 0 and 2 pi, this is 2 pi. So if the phase difference for lambda is 2 pi, we can find out the phase difference for various wavelengths. For example, this particular point is at lambda by 4. This is lambda by 2 and 3 lambda by 4. So I can do a calculation something like this, that if the phase difference for lambda is 2 pi, what would be the phase difference for a particle which is at a distance lambda by 4? So lambda by 4 will be how much? So lambda into lambda by 4 into 2 pi, that will give me lambda, and this 4 is in the denominator. So this will give me a value of pi by 2. And as you can see over here, the phase difference is 0.5 pi by 2 over here. So for 0.5 pi, our phase difference is lambda by 4. So this can be obtained. This is phase difference in terms of lambda. We can also obtain phase difference in terms of time period t. And again, for these 2 points, the phase difference will be t. So what will be the phase difference for different particles? We can find out this. Over here it will be t. So again this will be 3t by 4. This will be 2t by 4. This will be t by 4. This is 0, and I can put over here 5t by 4, 6t by 4, and 7t by 4. This is phase difference in terms of time period. This t can be written as 4t by 4. And 6t by 4 can also be written as 3t by 2, but to have uniformity, as to show that this is t by 4, this is 2t by 4, and 3t by 4, we have put it like this. So this is phase difference in terms of time period. Now, we have understood what phase difference is between the particles, and there are 2 more things that I want to talk about here. Phase difference. We have obtained phase difference of particles which had a lag of a. For all these particles, we took a lag of a. That means when this particle was over here, this particle was over here. And when this particle moved over here, this particle moved over here. So we very conveniently took a difference of a. But it is possible that the difference may not be a. Say for example, when this particle is over here and this particle is over here, the particle which is over here will be at this location. And let us say this is at distance x from the origin. So what would be the phase difference? And we will use the equation like something like this, that when When the distance is lambda, the phase difference is when the distance is lambda, the phase difference is 2 pi. So when the distance of the particle is x, what will be the phase difference? That will give me delta phi is equal to 2 pi by lambda into x. So I can use this equation for any particular particle if I want to obtain delta phi in terms of lambda. In fact, that's what we have done over here when we found out the phase difference in terms of lambda. So I can find out the phase difference of particles across this entire line which are placed at certain distance. So I have to take the value of x. For example, if I want to find out the phase difference of this particle, I take this value of x, put it over here, and I'll get the phase difference of that particle. So that's one phase difference in terms of lambda. Now, there is also a possibility that the same particle can have a phase difference. For example, this particular particle is over here, and the next second it's going to move. For example, let's go back over here. So this particle we know is going up. So if I take a snapshot of this wave after 0.1 second, this particle will be over here and the wave shape will change. So what is the phase difference of the same particle at two different points in time? And that we can obtain by this, that when the phase difference is time period t, when, when the two particles are at time t apart, the phase difference is 2 pi. So if they are small t apart, some time difference, what will be the phase difference? And in this, I'll get the equation delta phi is equal to 2 pi by t into small t. And I can obtain delta phi in terms of t. Let me repeat. This is the phase difference of two particles at the same time x distance apart. And this is the phase difference of the same particle at two different times t seconds apart. And this is also this is how we can find out phase difference. So with this I summarize what we have discussed so far. We can obtain phase difference in terms of length by using this equation. We can obtain phase difference using time t over here, and this is phase difference. Now some authors, instead of using the phase difference, use a term known as phase shift. Nothing wrong with using this term, so you can call this as phase difference or phase shift. And they prefer to use the term phase difference when we have two waves. For example, if we have a wave like this, let's say one wave, and let's say there is another wave which starts from here and goes something like this. So if this distance is, let us say, lambda by 2, this is lambda by 2, or in terms of pi, if this is 2 pi, this will be pi. This will be pi by 2. So there's a phase difference of pi by 2 between the two waves. This wave and these two waves. So this wave is leading this wave by a difference of pi by 2. So this also is known as phase difference. So here the term phase difference is being used between two waves. And in this case that we had discussed, we are talking about one wave and the phase difference between various particles. So we have to keep this in mind always when we are looking at the term phase difference. Are we talking of two waves and the phase difference between them, or are we talking of one wave and the phase difference between the particles of this wave? And when we are talking of the same wave, the phase difference between the particles of the wave, they can be obtained in two forms, in terms of time, in terms of distance. So whatever term we use, we can use phase difference, phase shift, whatever, but we need to keep in mind these three things. One, this is the phase difference between two particles. This is also phase difference between two particles. But in this case, the phase difference is between two waves. Which one is lagging, which one is leading, and that also gives us phase difference. So remember, when you come across the term phase difference, try to find out which case are we looking at. Are we talking of the same wave, or we are talking of two different waves? And accordingly use equations given. Thank you.